LED strips have become the most popular way to install indirect accent lighting, and in those applications, an LED strip with 60 or even 30 LEDs per meter can produce an even lighting effect with minimal hotspots. But what if you actually want to see your LED strip? I spent a little over $600 on 10 different neon effect spotless LED strips, and we're going to test their brightness, power draw, color saturation, uniformity, mounting options, and ease of use to figure out which one is best for you. For $39 for 5 meters, the least expensive LED strip that I tested was this 12-volt RGB LED strip from BTF-Lighting. The BTF strip achieves a spotless look by using chip-on-board or COB LED technology to cram together a crazy 840 LEDs per meter. Sort of. In that number, they're counting each red, green, and blue LED separately. So to keep things standardized, I'm going to change that number to the way that we normally talk about LED strip density, which is the number of RGB groups, which still gives an impressive 280 LEDs per meter and 1400 LEDs per 5 meter strip. The BTF-Lighting strip is not individually addressable, meaning the entire strip needs to be the same color and it can't make patterns within the strip. The BTF-Lighting 12-volt strip doesn't come with a controller or a power supply, and the strip is not waterproof. And the strip is 10 millimeters wide. On full brightness white, the 12-volt BTF-Lighting strip consumed 39 watts and had a brightness of 260 lumens. And while the Shelly controller and power supply do have an idle energy consumption of around 0.4 watts with the LEDs off, non-addressable strips themselves do not have any standby power consumption. Next, also for a price of $39, is an almost identical strip from BTF-Lighting, but this strip is 24 volts instead of 12 volts, which typically helps with voltage drop over long runs. On full brightness white, the 24-volt BTF-Lighting strip consumed 54 watts, which is 15 watts more than the 12-volt strip, but at a brightness of 518 lumens, which is almost double the 12-volt brightness. Like the 12-volt strip, this is a non-addressable strip and has no energy consumption when powered off. Next, for $40, is a 24-volt RGB addressable COB LED strip from Potix. The Potix strip has a slightly lower LED density than the BTF-Lighting strip at only 210 LEDs per meter for a total of 1,050 LEDs in the 5 meter strip. But unlike the previous two strips, the Potix strip uses addressable LEDs, so different parts of the strip can light up in different colors. But I wouldn't call these strips individually addressable, since they're controlled in large banks that are 10 centimeters long, so each 5 meter strip has 50 controllable segments. The Potix strip is not waterproof and didn't come with any power supply or controller. The Potix strip is 12 millimeters wide. On full brightness white, the Potix strip consumed the most energy yet at 63 watts and had a brightness of 330 lumens. Addressable strips do consume energy in standby mode because the chips are always ready to receive color data, and I measured the Potix strip idle power consumption at 6 watts with all the LEDs off. Next, for $50, is this 24-volt RGBW COB LED strip from Super Lighting LED. By using a separate white LED chip, the Super Lighting strip will produce a more pure-looking white color while using less energy. The Super Lighting LED strip has the same density as the BTF-Lighting strip at 280 LEDs per meter or 1400 LEDs per 5 meter strip, but it actually has a slightly lower density of color LEDs due to the inclusion of that extra white LED channel. The Super Lighting LED strip is non-addressable, non-waterproof, and didn't come with a power supply or controller. The Super Lighting LED strip is 12 millimeters wide. On full brightness white, using the dedicated white LEDs only, the Super Lighting strip consumed only 21 watts and produced 192 lumens of warm white light. And when sending maximum power to all the LEDs in the strip, the Super Lighting strip consumed 68 watts and put out 594 lumens, making it the brightest yet. Up next, we have the first variety of the second type of spotless LED strip, which uses a completely different method for reducing or eliminating hotspots. Instead of increasing the number of LEDs, these strips use a flexible silicone diffuser with a more traditional LED strip inside. The LED strip fires sideways into the silicone tubing, causing more diffusion and increasing the spotless effect. For $50, the first one we're going to test is this 12-volt RGB strip and diffuser from Lemomo. Unlike the other strips we've seen so far, the Lemomo comes with a 12-volt power supply and Bluetooth controller included in the price. The Lemomo has a much lower density than the other strips at just 100 LEDs per meter or 500 per strip, but as I said, it relies on that silicone diffuser and side-firing orientation to make a more spotless light source. The Lemomo strip is non-addressable, but Lemomo claims that it's low heat, fully waterproof, and fireproof? The LED diffuser itself is 5 millimeters wide and 12 millimeters tall and doesn't come with any double-sided tape attached. Testing showed that the Lemomo draws 60 watts on full brightness white, and I measured a brightness of just 35 lumens, which shows that a significant amount of light gets blocked by that LED diffuser. Using the included power supply and controller, the standby power was 0.9 watts with no lights on. Also for $50, Lumomo makes another variety of spotless LED strip, but this one is a 24-volt RGB addressable strip. Like the non-addressable Lumomo, this one comes with a power supply and controller, though this one uses an infrared remote instead of Bluetooth control. The LED diffuser is 17.5mm tall and 8mm wide, and it doesn't come with any double-sided tape for mounting. Like the COB addressable LEDs, this one is also not fully addressable and is instead controlled in 10cm segments for a total of 50 segments per 5-meter strip. This strip is also the least dense of any of the strips that I tested, with just 60 LEDs per meter or 300 LEDs per 5-meter strip. Lumomo does say that this strip is IP65 waterproof, but that doesn't make that same fireproof claim. In my testing, the Lumomo addressable strip drew 36 watts on full brightness white, and the output was just 13 lumens. And in standby mode, the Lumomo addressable strip and controller drew 1.8 watts. Sticking with the silicone diffusers, but bumping the LED density up significantly, is this $54 12-volt RGB addressable strip from Aclarol, which claims to have a total of 540 RGB LEDs or 108 LEDs per meter. Each addressable segment of the Aclarol strip is 5.5 centimeters long for a total of 90 controllable segments in the 5-meter strip. And like the addressable Lumomo strip, the Aclarol is IP65 waterproof, but unlike the Lumomo, the Aclarol doesn't come with a power supply or controller. The Aclarol strip is 6mm wide and 12mm tall. Set to full brightness white on the entire strip, the Aclarol drew 60 watts and had a brightness of 91 lumens, and with the power off, the Aclarol strip had 1 watt of idle power consumption. After that, for $65 is a very similar strip from Alitove, except that the Alitove has a slightly larger black diffuser. The Alitove strip is 12-volt RGB addressable with 108 LEDs per meter for 540 LEDs per 5-meter strip. Each addressable segment of the Alitove is 5.5 centimeters for a total of 90 segments on the whole strip. The Alitove is also IP65 waterproof and doesn't come with a controller or a power supply. The Alitove strip is 6mm wide and 16mm tall. I powered the Alitove with the same 12-volt 10-amp power supply and Dig Uno that I used with the Aclarol strip, and I measured about the same amount of power consumption at 59 watts, but with a brightness of just 18 lumens, which is 5 times less than the Aclarol. And in standby mode, it had that same 1 watt idle power consumption. After that, for $70 is the most expensive COB LED strip that I tested, the Top XCDZ 12-volt addressable strip with 240 LEDs per meter for a total of 1,200 LEDs per strip. Each controllable segment on the XCDZ is 5 centimeters for a total of 100 segments on the whole strip, which is the most yet. The XCDZ doesn't come with a controller or power supply, and the XCDZ is also not waterproof. The strip itself is 12mm wide. I measured the XCDZ on full brightness white at 57 watts and a very respectable 424 lumens. The XCDZ had a standby power consumption of 1.4 watts with no LEDs lit up. Last, the most expensive LED strip that I tested was this $100 Govee RGB IC neon rope, which is a 24-volt addressable LED strip and silicone diffuser with a density of 84 LEDs per meter or 420 LEDs in the 5-meter strip. Each addressable segment on the Govee is 11 centimeters long for a total of 45 segments, but in the app the strip is only broken down into 15 controllable segments, so you can only see those 45 segments during animations. The Govee neon rope comes with a power supply and a Wi-Fi controller, and Govee specifically points out that the strip itself is waterproof, but the power supply and controller are not. The Govee diffuser is relatively large compared to the other strips at 17mm tall and 10mm wide. Using the included power supply and controller, I measured the Govee's power draw at 76 watts on full brightness white, which produced 57 lumens, and standby power consumption with no lights on was significantly higher than the rest of the strips at 11 watts. You can see that the brightness of the COB LED strips was quite a bit higher than the silicone diffuser type, with the Super Lighting 24-volt RGBW strip putting out the most lumens at 594 when using every LED, while the BTF-Lighting 24-volt RGB strip put out a respectable 518 lumens. In contrast, the brightest silicone diffuser strip was the Aclarol with over 5 times less output with 91 lumens, and the dimmest strip was the Lumomo 24-volt addressable strip and diffuser producing just 13 lumens. I also calculated each strip's efficiency by dividing the brightness by the power draw, and the BTF-Lighting 24-volt strip came out on top with 9.6 lumens per watts compared to the brightest silicone diffuser strip, the Aclarol, with just 1.5 lumens per watt. And the least efficient strip was the Alitove, which was almost identical to the Aclarol except for a slightly larger black diffuser which only output 18 lumens on full brightness white, consuming 58 watts for an efficiency of 0.3 lumens per watt. However, for these strips, it's not just light output that's important, since they're also advertised as having a spotless neon effect. So during my testing, I gave each strip a spotless score, with 1 being very visible spots and 10 being completely spotless. The worst performing strip with a spotless score of 5 was a silicone diffuser strip, the Lomomo 24-volt addressable strip, which not only had terrible brightness and efficiency, but also had clearly visible LED hotspots due to its low 60 LEDs per meter density. However, the 2 best performers were also silicone diffuser strips. The Lomomo 12-volt strip and the Alitove addressable strip both scored a perfect 10 and had 0 visible hotspots. Of the 2, the Lomomo 12-volt strip had double the light output at 36 lumens versus 18 on the Alitove. For the COB LEDs, the top XCDZ strip had a score of 8.5 due to its high LED density, but if I was looking directly at the strip, I could still make out the individual LEDs, since the RGB LEDs are placed on the strip in a line instead of in a cluster like a traditional LED package. The Super Lighting RGBW COB LED strip also performed very well when using both the white and colored channels. So while none of the COB LEDs scored a perfect score, it's also important to remember that since they aren't using a silicone diffuser, their brightness is over 10 times higher, with the top XCDZ putting out 424 lumens and the Super Lighting RGBW strip producing 594 lumens in its most spotless configuration. The next set of measurements were for color saturation, because in addition to measuring the white brightness, I also measured the lumen output for red, green, and blue. Under normal circumstances, we would expect the white output to be equal to the red, green, and blue outputs added together, with maybe a slight reduction based on voltage drop. But for strips that include their own controller, those companies may try to boost the brightness of individual colors by adding a little bit of light from the other LEDs, which can result in a washed out, less saturated color. For example, we can see that the Govee strip's individual colors add up to 182% of white brightness. And when comparing the red Govee strip to the rest of them, you can tell that it has less saturation in order to try to boost that brightness. And the same trend is even more visible in the pure green color, but the pure blue has full saturation. Likely because out of the 3 color LEDs, blue has the highest lumen output and doesn't need to be boosted. The same pattern can be seen, but to a lesser extent, with the Lomomo 12-volt and 24-volt strips, which also use their own controllers. The best color saturation came from the 24-volt BTF-Lighting non-addressable strip, followed closely by the Super Lighting RGBW strip, and in third was the top XCDZ. Unfortunately, it was difficult for me to judge the color accuracy and saturation of the Alitove strip because the individual colors were just too dim. I also looked at color uniformity, meaning how close the color was at one end of the strip to the color at the other end. This type of discoloration is caused because as electricity travels down the strip, the voltage gets less and less due to the resistance in the copper traces, which is called voltage drop. 6 out of the 10 strips had no visible difference in color between the beginning of the strip and the end, but the Govee had a very slight difference in the last 10% of the strip, and the Lomomo 12-volt, Alitove 12-volt, and Acrolol 12-volt all started losing color accuracy around the last 25 to 30%. Fortunately, the Alitove and Acrolol have wiring at both ends of the strip, so you can solve this issue by connecting a 12-volt power source to the opposite side. But the Lomomo 12-volt is sealed on the end, making power injection impossible. For the strips that can be daisy-chained together for longer lengths, I measured the voltage drop at the end of the strip, and I found that, as expected, the 24-volt strips have the least voltage drop and can therefore handle a longer run without any color inaccuracies. The Super Lighting 24-volt RGBW strip performed by far the best, with just 0.2 volts of drop using only the dedicated white LEDs, and amazingly only 0.8 volts of drop with all the LEDs at maximum brightness, indicating that it has high-quality copper traces within the strip. Another big difference between the 2 types of strips is how they can be bent around corners. Typical LED strips can only be bent forward or backwards in relation to the light source, so when going around a 90-degree corner, the easiest solution that doesn't involve cutting the strip is to make a loop. But since the silicone tubing style uses side-firing LEDs, they actually bend left and right in relation to the light source, which makes it easier to make shapes and designs. As far as the malleability of the silicone diffusers, I found that the Govee, Alitove, and Acrolol were all extremely easy to bend, and although probably not recommended, could be folded 180 degrees without destroying the strip. The Lomomo 12-volt strip was also malleable but couldn't quite make a 180-degree turn, while the Lomomo 24-volt strip was thick, rigid, and very hard to work with. Last, let's talk ease of use and features. When it comes to LED strips, Govee is the king of easy to use. The Govee strip comes with a power supply, controller, mounting hardware, instructions, and an easy-to-use app. Similarly, but for a lot less money, the Lomomo 12-volt strip came with mounting hardware, a high-quality power supply, a controller with on-device buttons, an infrared remote, and a phone app, making it really easy to get set up and working. Unfortunately, the Lamomo 24-volt strip came with a low-quality power supply and a controller that can only work with an infrared remote and a bunch of unlabeled mystery buttons that make random patterns and colors, making the individually addressable aspect of the strip pretty much worthless. The rest of the strips will require you to buy your own power supply and choose your own controller, which can ultimately give you more options and higher quality parts, but it does come with an added level of difficulty that some people might not be comfortable with. I personally use the Shelly RGBW2 whenever I need to control non-addressable strips, and the Dig Uno or Dig Quad with WLED when I'm setting up addressable strips. And I've got links down in the description for those, as well as some good quality power supplies that I've personally used. So which strip is going to be best for you? Let's start with that silicone diffuser type. If you want to make a design or some art on your wall, the value of the Lamomo 12-volt strip is hard to argue with. For $50, you get a power supply, Bluetooth controller, remote, and a thin, easy-to-bend strip that has a near-perfect spotless effect, good color saturation, and decent brightness. My only issue with the Lamomo 12-volt strip is that there was some color inaccuracy at the end of the strip compared to the beginning. So if you're bending the strip around so that the ends are going to be right next to each other, there may be a slight difference in color and brightness. If you're looking to buy your own controller and power supply, the Aclarol silicone diffuser strips are the best option for wall art. But I'd recommend connecting power at both ends of the strip to avoid color inaccuracy due to voltage drop. Also be aware that while the Spotless Effect is pretty good, it's not as perfect as the Lamomo 12-volt strip or the Alitove, which I can't recommend simply because of how inefficient it is. As for the COB LED strips, the clear winner for me was the super light RGBW LED strip, which had great color saturation, super high efficiency, a very good spotless effect when using all the channels, and of course that dedicated white LED channel, which gives you a much more pleasing white output than you would get using RGB. If you're looking for an addressable strip, the top XCDZ was the best performer with the best spotless effect, highest LED density and most addressable segments, and very good color saturation. And last, just for fun, I decided to make one strip to rule them all. By using the 24-volt BTF-Lighting RGB strip and an add-on Mazada side-firing silicone diffuser, you can get a very bright, extremely well-diffused strip for a total of $70 if you're willing to do a little more assembly and DIY. For reference, adding the silicone side-firing diffuser decreased the full whiteness bright from 518 lumens to 98 lumens, which is a 5 times reduction. But even with that brightness reduction, it still makes this DIY solution the brightest and most efficient of all the silicone diffuser options. And it is completely spotless at any brightness. In fact, I think this might be the only option that I reviewed that doesn't have any downsides other than the price and needing to put it together by yourself. Links to everything that you saw in this video are down in the description, and as always, there are no sponsored reviews on this channel, and I bought everything that you've seen today with my own money. However, the links in the description are affiliate links, so if you appreciate the time, effort, and money that it takes me to make a video like this, I'd appreciate if you could use those links since I do earn a small commission on the sale at no cost to you. Thank you so much to my awesome patrons over at Patreon for your continued support of my channel, and if you're interested in supporting the channel, please check out the links down in the description. If you enjoyed this video, don't forget to hit that thumbs up button and consider subscribing. And as always, thanks for watching The Hookup.